Hi, I'm Stephen Wolf. Welcome to CMR Practically Speaking, where we explain things in 2 minutes, even if they took a lot longer to figure out. In this episode, I want to show that flow quantification in large vessels like the aorta is far less sensitive to imaging plane orientation than many people assume, and why even fairly large obliquity by itself isn't a reason to discount flow values. I'll then explain some practical limits that become important as vessels get smaller. Here's a real 4D flow example. The red plane is perpendicular to the descending aorta. The blue plane is tilted by 40 degrees. As expected, the oblique plane shows a larger apparent area and lower velocities. But when those lower velocities are integrated over the larger area, the total flow is maintained. So why does the old rule, image perpendicular to flow, exist? Here's why. In a large vessel, most pixels lie fully within the lumen. Only a thin rim at the boundary contains partial volume pixels. In a smaller vessel, far fewer pixels are fully blood-filled. In this example, there are 16. Simulation, phantom, and clinical studies suggest that accurate flow measurement requires 12 to 16 fully sampled lumen pixels. Now tilt the imaging plane. The large vessel still contains many fully blood-filled pixels. The small vessel does not. In this example, that number drops to 12. And this is the key point. With obliquity, you don't just change the apparent area, you lose fully sampled blood pixels. So the practical takeaway is this. In large vessels, not perfectly perpendicular is often used to explain a flow value that doesn't make sense, even though obliquity is rarely the limiting factor. When flow looks off, look for other causes first, before blaming plane orientation. Thanks for watching. See you next time on CMR Practically Speaking.